So today's topic is cutting tools in CAM. And we will be breaking this down into two parts. And the first part, we will cover the topics that you see on this current slide. We will talk about creating standard tool types and setting tool properties, and also creating and using custom tools or user-defined tools. And then in terms of reuse of tools, we will talk a little bit about the pre-installed libraries that come with the product. And in addition to that, creating a tool library of your own based on your environment and your requirements. And then we'll talk a little bit about how to load the tool library. And then we will cover some of the functions in the Tools tab and the toolbar functions that are available in that tab. And then finally, talk about cutting tool preferences. And we will go through a demo for these topics. And after we do that, we have a second set of topics that we'll talk about. And that's going to be in terms of, commonly asked questions, frequently asked questions in terms of things like, where can I find tool-related preferences? How can I print a tool list? Can I output the tool list in the posted code? And then we'll get into a little bit more detail in terms of, feed rates, tapping feed rates, optimizing machining time estimates, and then, also talk about adding tool comments, tool change points, materials, cutter compensation, and so on. So there is a lot to cover both in the first part of the demo and in the second part where we will get into more detail and show you where you can find this information and how you can do these things that you need to do. All right. In terms of the topic that we will cover first, we'll talk about standard tool definition. And Uday will run us through the slides that we're going to go through right now. Uday will run through a demo, and he will actually walk us through the different steps of defining standard tools. And then we will talk about custom tools or user-defined tools. And here the example on this slide, we are showing on the left-hand side within our application how you would define the tool. And then on the right-hand side, you see a picture of basically a simulation of using that tool in the profile operation. And so we'll cover this detail as well in terms of custom tools. And then we will talk about the Tools tab. The Tools tab is the machining objects browser, and we will go through the functionality and the features available within the Tools tab, and we'll go through that in detail. And so that would be part of the first part of the demo as well. And once this demo is done, I will be handing it over to Uday now. Once the demo is completed, Uday will then walk through the second topic, which was the frequently asked questions. All right, so now I'm going to go ahead and hand it over to Uday. And thanks, Uday. Go ahead.
Thank you, Krish. And hello, everyone. Good morning, good afternoon, good evening to you folks. And thank you for joining us for the AMS webinar series. And as Krish pointed out, today we're going to be talking about all about cutting tools and tool libraries. And this is a very popular topic as, for all your application, all your programming needs, you would have to define tools and how you can effectively create your tools, create the different tool types, save them to libraries, use the default library. So we'll cover each of those, as we go through the webinar today. Now, these features that we're going to cover today are common to all our products, whether you're running our flagship standalone visual CAD/CAM, or you could be running our plugin for Rhino, which could be Rhino CAM, or your plugin for SolidWorks, our visual CAM for SolidWorks, or even if you're running a Libre CAM, the workflow and these steps are going to be exactly the same. So first, I'm going to be starting out with our visual CAD/CAM application, and we'll go through the process of how we could create standard tool types and setting the tool properties. I hope everybody is able to view the screen. If you're having trouble, please go ahead and click on the raise hand button so we can make sure that there aren't any technical issues and you're able to see it. Now, as you load the application, there is two halves to the browser. You have your machining operations browser, or the machining browser, which typically appears on the top half, and then the browser window, which is called the machining objects browser, which appears by default on the lower half, or you could have it docked over on the side of your machining browser itself. So the Tools tab can be located under the machining objects browser. Now, if for any reason you're unable to view the Tools tab or the machining objects browser, you would need to select the toggle Tools Machining Objects icon, which is found just to the left of the Program tab in your machining browser. So when you click on Tools and Machining Objects, this will display the Machining Objects browser right below the machining browser, or if you had it docked over to the side, it'll appear right next to it. Now, this is how it'll work in Visual CAD/CAM and RhinoCam. If you're running Visual CAM for SolidWorks or AlibraCam, you will see the machining objects browser docked or appearing below the machining browser. So once you have the machining objects browser visible, you will notice that the Tools tab is the very first tab that appears down under the machining objects browser. Now, under the Tools tab, you have different controls in here, and during the webinar we'll cover each of these. The first thing I'm going to go over is creating tools. So as you select Create Edit Tools, this brings up your Create Edit Tools dialog, and it lists all the different tool types that are available to you. Now, the tool types that you're seeing here are available in all of our configurations starting with standard. So if you're running standard, expert, pro, or premium configuration, you will have access to all of these tool types. And as you hover your cursor over these tool types, you'll see that the tool tips would appear representing each of the tool types. So we have tools of type ball and mills, flat and mills, corner radius tools, tools for engraving, chamfer, taper tool, thread mill, face mill tools, dovetails, fillet mills, lollipop cutters. We have user-defined tools, which we're going to be covering as well. And then we have drill, center drill, reamer, tap, bore, and reverse bore. Now, you could define tools under each of these tool types. So, for example, let's consider a flat mill. So for parts that you would be using 2.5 or 2-axis programming that are mostly prismatic parts like the one that we have showing up on the screen here, you would be wanting to use typically a flat mill for a facing or a pocket or a profile operation. So you could define tools in here. So we would pick a tool type first, and then you would specify a name for the tool. You would want to specify a tool name that's easy for you to locate and access them. So typically I would call it flat mill, and I would put in the diameter to identify the name, specify a tool name, specify the tool diameter in here, and then also specify the properties of the tool, like the flute length, the shoulder length, the tool length. Now, as you specify these properties in here, you could either enter in the values or use the spinner increment to specify it. You'll notice that the preview of the tool is also automatically being updated in here. As you make changes to the tool, you will notice that the tool preview automatically updates. So you can specify the parameters for your tool length, shoulder length, flute length, your shank diameter, holder diameter, and the holder length can go right in here. So once you have these parameters defined, you then want to go over to the Properties tab over here on the right side, where you can specify the material for the tool. You could be setting it to carbide, high-speed steel, or ceramic. So once you specify the material type, you could also assign a color for the tool material. This is something that's new in version 17. This can be used for cut material simulation. So you can assign colors for cut material simulation based on the tool. So you can have a color set for each tool that you're working with. So you could specify that. And then you could set the number of flutes. It could be a 2, 3, 4, the number of flutes for the tool. And the most important parameters are your tool numbers, your address register, and CAMJam register. Now, the tool number, if you're working with a machine tool that has an automatic tool changer, you would want to make sure that you set the tool number according to what's on the machine in your, for your tool change. If you have 1 inch end mill is on tool 1, you would want to make sure that you put the tool number as 1 in here as well. Now, the address register, defines your tool height offset register. Typically in the posted output file, this is output as a G43H and then a value, and this basically points to your tool table to obtain the height offset. And in most cases, you would set the address register number to be the same as your tool number. So you would want to make sure that you set the tool number and then your tool address register, which is basically the height offset register. And then if you're using curve compensation, like a G41 to compensate left or G42 to compensate right, some controllers expect you to also output a cutter comp register like a D followed by the register number. And in most cases, you would also be setting this to be the same number as the tool number because it points to the table for the cut comp register, and the value that you're going to be compensating is what you would enter in the controller's tool table for the cut comp. So basically this maps to the tool table's registers. So you would want to specify these. Now one of the nice things what we do in our CAM system is we automatically set these address and the cut comp registers to the same as your tool number, so just to make it easier for you. So if you leave these as 0, then you wouldn't be applying any offsets for your height offset or cut comp register. So we automatically make sure that your address and the cut comp registers are set to the same as your tool number. But you do have the ability to go back and override it and make changes to it. Now finally, you have what's called the axial offset. Now this is this value can be set if you'd like to offset the tool path axially, meaning if you're doing a 2 or a 3 axis operation, an axial offset would be an offset in the z-axis. So by specifying a positive value for the axial offset, this would offset your tool path, the program tool path in the z-axis by the specified value. If you put in a negative offset, the tool path would be dropping further down in the z by the specified value. By default, this value is set to 0, and if you specify a value for the axial offset, this would apply for all the operations that you program with this specific tool, and you will be able to notice the toolpath being offset in the toolpath preview once you have the toolpath generated. Typically this would be set to 0. You could use the axial offset if you need to offset it. Now the next thing is your coolant. You have the coolant choices in here. You can specify the coolant type. You could set the coolant, by default it's set to none, or you could set it to flood, mist, or through. And the coolant codes, the M codes for coolant can be defined in your post processor, whether they're M8, M7, whatever that needs to be based on the coolant type. Those can be defined in your post processor. Now you also have a section in here where you can enter in comments for your tool. The comments can be a single line comment, or it could be even using a multi-line comment where these can be specified. Now for example, if you want to output the tool name or the also the SKU number from where you source these tools, so that if you have multiple end mills of the same size but you want to use a specific tool from a specific manufacturer, you can enter in those comments, and those comments can also be output in the posted code at the start of the operation. So you could specify a comment. The comments could be a single line comment, or you could have a multi-line comment as well. There's also one nice feature in this comments section. Typically the comments are output in the posted code with the comment start and end character, but if you want the comment to be output as a line of code without the comment start and end characters, you could output by adding a prefix $sign as a prefix, and you can specify the comment to be output. For example, if I need to output an optional stop in here, I can put in a dollar and then an M00 or an M01. So instead of outputting the comment with the comment start and end characters, it will be just outputting as a normal regular line of G code in here. So you can specify it with a dollar as a prefix sign, and you will find that the comment is not output with the comment start and end characters that you define in the post. So once you have the properties tab filled in here, the next step is to go into the feeds and speeds tab, where you can set the feeds and speeds, the spindle speed, the feed rates, the plunge, cut, engage, retract, departure feed rates, transfer feed rates. Now you could set these parameters, or you could use the load from file. So if you refer to the previous webinar that we had last month, you can learn more about how you can set feeds and speeds. We had a topic full of how to use the feeds and speeds and the properties, on a separate webinar, so you can go back and visit that. So I'm not going to go ahead and cover the feeds and speeds topic in here in detail, but you can set the feeds and speeds for each tool that you're defining. And once you have these properties defined, you'd want to click on Save as New Tool. Now, once you have a tool defined in here, if you'd like to make any changes or edits to it, you can go ahead and make those changes in here. So for example, I can modify my tool, and once I make those changes, I would select Save Edits to Tool, so these edits would be updated on the particular tool. Now when you pick OK, this tool that you created is listed under the Tool tab in the Machining Objects browser. Now you can have one or more tool of each tool type defined in here, so you can go back and edit it. And if you'd like to add a new tool of the same tool type, you need to make sure that you have to specify a new name for the tool. You cannot have two tools with the same name assigned to it. So you need to specify a new name for the tool. As you can see, the Save as New Tool option is grayed out because I cannot define a second tool with the same name. So I'm going to go back in here and change the tool name to a 1/4 inch. And once I make a change, you'll see that the Save as New Tool option is now enabled. I can enter in the properties for the tool. Now with our 2017 version, you could also use fractions to enter in your tool properties. If you want to define a 1/4 inch end mill, I could say 1/4, and we can automatically compute that in decimal. You can do that for any of these fields in here. You can specify those properties. You can set you can update your comments as well. And as you notice here, once I select Save as New Tool, with leaving all the other parameters at the default settings, since I have not modified the tool number or the address register or CAMJam, when you select Save as New Tool, you're being prompted with this dialog saying tool number is repeated, and would you like to use a non-repeated tool number? So as you select yes, as I mentioned earlier, the tool number is automatically incremented by the next available number. And you'll also notice that your address register and the CAMJam register is also set to the same as your tool number. So that saves you the time to going back in here and editing and setting the address and the CAMJam registers in here. So once you have established the properties for the tool as well as your feeds and speeds in here, you could select Save as New Tool, which I just did. If you make a change, you would select Save Edits to Tool, and those edits are saved. And you'll now notice that we have two tools in here under the type flat mill. We have a 1/2 inch flat. We also have a 1/4 inch flat. Now as you select these tools that are appearing in session, you will notice that those tool types, the tool properties are displayed in the dialog. So selecting OK again will automatically display the tools that you just defined in here. Now you can create tools under each of these tool types. You can define tools of type ball mill, other types. So let me go ahead and add a ball mill tool in here. I'm going to specify a tool name, specify the properties for the tool, and you'll notice that the tool number, as you switch from one tool type to the next, it automatically assigns the next available tool number. So since we already have two tools defined in here, we have tool 1 and 2, it automatically sets the next number to 3. You pick Save as New Tool. Now if you want to add a new 1/4 inch ball mill, you'd want to go back in here again and change the name for the tool, specify the tool properties, and once I set the tool properties and I've changed the name, you'll see that the Save as New Tool option is now available. I'm going to pick Save as New Tool, and again, since the tool number is being repeated, I'm going to select yes to use a non-repeated tool number, and you'll now notice that the tool numbers are numbered 1 through 4, so the first two tools are flat end mills, and tools 3 and 4 are ball mills. So once you have these tools defined in here, they appear under the tools in session. So these tools, what you created in here, are now available for programming on this particular part that you have open in session. So you could basically go ahead and program your toolpaths using these tools. Now, one of the common things that we typically are asked for is how can I use these tools on other parts that I'm going to be programming? How can I utilize the same tools? Like how do I save my tools to a library, and how could I use these tool libraries on other projects? So I'm going to talk about that here in just a moment. So now once you have these tools defined in here, if you go over to the Tools tab, you'll see that there's options for loading a tool library, which I'm going to talk about in just a moment. And we also have the option to save tool library. Now, since I have these tools already defined in here, I'm going to click on Save Tool Library. So this would allow us to save the tools that we defined to a library, so the same tools can be used on other parts, other projects that you're working on. So in this particular case, I'm working in inch units or English units. So the tools what I've defined are also in the same units in here. So I'm going to go in and save the library. Now by default, the tools are saved under the data folder. Now the data folder, a lot of us might be wondering where this data folder is located. So if you go into your File Explorer and you go under the drive where you have your operating system installed, which is typically the C drive, you go into the C drive and you would go under Program Data. So the program data by default in Windows is a hidden folder location. So you might be wondering, how can I view the program data folder if the folder is hidden? So in Windows, you can go into your control panel, or if you're, you can type in Show Hidden. So if you type in Show Hidden from your search bar in Windows, it'll take you to the control panel item called Show Hidden Files and Folders. As you select Show Hidden Files and Folders, it brings up the File Explorer options, and under the View tab, you will find Advanced Settings, and under Advanced Settings, by default, it's set to Don't Show Hidden Files, Folders, or Drives. You just have to go ahead and click on Show Hidden Files, Folders, and Drives. When you make this visible by selecting Show Hidden Files, Folders, and Drives, and then pick Apply and OK, the Program Data folder is going to be visible whether you're running Windows 7, Windows 8, 8.1, or 10. The way you access the Hidden Files folder options is the same. So you go into the Program Data folder. Now under Program Data folder, you would want to go into MecSoft Corporation. Under MecSoft Corporation, you would want to choose the product that you're running. If you're using Visual CAD/CAM standalone product, you would go into the Visual CAM 2017 folder. If you're using a plugin for Rhino, then you would go into the Rhino CAM 2017 for Rhino 5 folder. Or if you're running a plugin for SolidWorks, you'd go into the Visual CAM 2017 for SolidWorks. Or if you're using our Alibre CAM product, you'd go into the Alibre CAM 2017 folder. Now, since I'm working in the Visual CAM 2017 product at the moment, I'm going to go into the Visual CAM 2017 folder, and you will find a bunch of these subfolders in here, and the data folder is where you will find the default English and metric tool libraries, and when you try to save your tools, by default it's going to point to the same folder. So this is in the application, I'm going to choose Save Tool Library, and by default it points to this folder. Now you could pick a different folder of your choice if you'd like to, but this is the default location where it actually points to, and the Save As Type also by default is set to Tools from Knowledge Base Files format. Now there is two types of tool library formats our CAM products support. One is the Tools from Knowledge Base format, which is VKB, and we also have a format called CSV, which can be editable in a spreadsheet application like Excel or any other spreadsheet application that you could use. We typically recommend using the knowledge base format as it has more control and more features. If you'd like to be able to edit the tool library file, you're welcome to save them in the CSV format. You can put it into a spreadsheet and make edits. There are some limitations in those, and we'll talk about that as we go through the webinar. Now for now, I have these 4 tools created, and I'm going to save them as My Tools. Now I could be saving these tools based on the machine tool I have. If I have one or more machine tools I'm working with, I could be saving them, assigning a name based on the machine tool, or if you're working based on different types of cutting materials like wood, aluminum, steel, you can have tool libraries saved based on the material you're working with. So I'm just going to call this my tools and then save it. You will now notice that it confirms with a message saying 4 tools have been successfully saved into your library. So we defined some tools in here and we saved them to a library. Now on the same Tools tab, you have the option to list all the tools that you've created. So if you go to List Tools, you will find that each of the tools that you created in here are listed, and any comments that you specified can also be found here. So you will notice that we have 2 tools of type flat mills and 2 tools of type ball mill, and the common properties of each of these tools are listed right in here. And you can also select Print to print the tool list directly from here, and you can send it to your printer. Now, you might be wondering, does our CAM product have a tool library that's included by default? Yes, we do have tool libraries that are included by default, and we'll show you how to locate them. So if you go into the Load Tool Library option, which is right next to the Create Edit Tools on the Tools tab, this takes you into the Data folder by default. And if you look under the Tools of Type, if you change it from Tool Library Files to All Files in here, you will notice that it automatically shows the 2 default tool libraries that are included with the installation of the product. So we have one for English tools and one for metric tools. So if you're working in inch units, your units can be identified in the status bar. If you're running Visual CAD/CAM or Rhino, the same thing also works in SolidWorks. You can go to your document properties to check the units, or you can go into a Libre design to check the document properties as well. So you can select the tool library here, default English tools and metric tools, and pick Open. And this automatically loads 56 tools from the library in here. And you can edit these tools and customize the library. So as I go into the tools in here, you will notice that there are tools of type ball and mills, flat end mills, corner radius tools, tools for engraving, chamfer. So you have tools under most of these tool types in here, and these tools can be customized, and you can go back and set your tool numbers. Now the default English and metric tools that you load from the library, they do not have any tool numbers or address registers being set, because these could be different for each of the machine tools that you may be using. So you want to make sure that you load the default tool library and use this as a reference to customize it to build your own tool libraries. And once you have these defined in here, you can go back and save the tool to a library, which we just did a couple of minutes ago. So we loaded the default tool library, and now if you can go back and customize it, make those necessary edits so that they are according to what you need for your application, and then you save the tool to a library. Now let's look at how we can use the same tools on other other projects. So when you load a tool library into the CAM application, which could be Visual CAD/CAM or Rhino CAM or Visual CAM for SolidWorks or Libre CAM, the last loaded tool library is remembered by the application. And the next time you open up a part, if I select File and New or File and Open another project, it automatically loads the last loaded tool library in here. So as you can tell, I loaded the default tool library, which was the default English tool library. And when I open up a new file or when I open up another part, it automatically loads the last loaded tool library. And this information is being saved under the CAM preferences, and under cutting tools, you will notice that it's automatically set by default to load the last loaded tool library on startup, which means the next time you open the application, the last loaded tool library gets loaded automatically. If you want to stop that from happening, you can just clear this checkbox, and you can also then pick OK, so it's going to stop the tool library from loading. Now if you wanted to unload these tools that you currently have loaded and open up a different tool library in here, there's an option in here called Unload Tool Library. So which is going to unload the tool that you currently have loaded. And you can pick a library that you wish to load, and I can go back and choose the library I just created a few minutes ago, which is called My Tools, and I'm going to pick Open. And you will now notice that the 4 tools we created during the start of this webinar, we have it loaded. Now when I go back and open up the part we were working on, you will notice that the 4 tools are automatically loaded. So Visual Mill, or RhinoCam, a Visual Mill for SolidWorks will remember the last loaded tool library, and it automatically loads them on each and every project you work on. So this is how easily you can have the tools that you created and saved to a library load on each project that you're working on. Now there's also other ways to load tool libraries. So I'm going to unload these tools in here. And if you only want to load a specific set of tools from a library, let's say your library has hundreds of tools, and for this particular project you only need to load a couple of end mills. So rather than having to load all of these tools from your library, you can choose the option to what is called a Select Tool from a Library, and then you can go find the library that you'd like to use in here, and then when you pick Open, this displays the dialog called Select Tools from the list, and you could select a tool and simply drag and drop from the tool list to the tool tab. Now as you drag and drop, the tools are not being removed or deleted from your library. The list is just being updated so that you don't have duplicate tools in here. So as you drag and drop, you're seeing that the 2 end mills are now no longer appearing in the list, but they're still in your master tool library that you created. They're not being removed here. So they're just being moved to the Tools tab under the machining browser. So you can use the drag and drop functionality as well to load your tools from a library. So as if you go back and click on Select Tool from Library again, you will notice that these tools are still in your library. If you go back and drag and drop the tools again on it, you'll be prompted with this dialog saying that the tool of the same name is already available in the Tool tab, and would you like to replace it? So if you had made changes or if you had made updates to your tool library, let's say you may have modified your flute length, or you may have updated your feeds and speeds or some of the properties, and you wanted to load the updated settings, you can go back and do a drag and drop or reload the library, and you'll be prompted, would you like to replace the existing tools with the ones in the library? So as you pick yes, it automatically updates them from the library. So you could load a library, or you could select a certain set of tools from a library and have them loaded for the part of the project that you're working on. So going back to the topics in here, so we covered how to create standard tool types, and we talked about how to set the tool properties. The tool properties are the number of flutes, the tool number, your adjust register, your cut com register. We talked about the axial offset, the coolant, and also we talked about the comments in the tool. We also talked about how to create a tool library, and also we talked about how to, I'm just going back to the slide in here to the topics here. We also talked about how to use a pre-installed tool library. We looked at how to create a tool library, how to save a tool library, loading tool library. We also looked at the Tools tab and all of the different options that are in the Tools tab, like create a tool, load tools, select tool from a library, save tool to a library, unload tools, and we also we're going to look at some of the cutting tools preferences as well. So now the next thing I'm going to cover here is how to create the custom tool or the user-defined tool, which is part of our topics in here. So for that, I'm going to go into our RhinoCam application in here, and we'll go through an example for that. So what I have here is a furniture design. It's a table in here, and on this particular table, I have a profile on this table I would like to cut. Now, rather than using end mills and ball end mills to program these, for a lot of these applications, you might have a custom cutter that has the profile of the shape that you want to cut for applications like these. So one of the nice features you have in our CAM product right from the standard configuration is the ability to define user-defined tools, or also known as form tools, because it takes the form of this particular profile that you have in here. Now, in order to create a user-defined tool or a form tool, now this workflow is exactly the same whether you're running Visual CAD/CAM or Rhino CAM or Visual CAM for SolidWorks. The first thing you would need to do is go into your XY plane in the host CAD system, whatever you're working with. In this case, in Rhino, I'm going to be the top view is basically your XY plane, and then you would want to go in and define what is called, I'm going to go into the layers in here, and basically you would want to define a cross-section of the tool. So the tip of the tool needs to be at the origin, and you would basically model 1/2 of your tool profile. So I've created this as a curve in Rhino in here, the tool profile, and I'm going to go over and bring that in here. So as you can take a look right there, so we have 1/2 of the cross-section of the tool profile defined in here. So your tool tip needs to be at the origin, which is XY0. So if you're running SolidWorks, you would be defining this in your front plane, which is typically your X and Y plane. So you would want to make sure that the tip of the tool is at the origin. So your origin is your XY0, and then you would have to create an open curve, and you need to make sure they're all joined. So if they're exploded, make sure you join them together. So you model 1/2 of the tool profile. Now once you have this created, you just have to highlight it or select it, and then you go over to your Tools tab, and under the Tools tab you want to click on Create Edit Tools. Once you go to the Create Edit Tools dialog, you'd want to go into your user-defined mill, and once you go into the user-defined mill, as you already have the profile that you created highlighted, you'd want to specify Load Selected Profile Curve. Once you select it, you'll notice that the profile of the tool curve that you selected, the tool is defined based on the profile of the tool. You can specify your properties like a holder diameter, any additional parameters that you want to define. You can set your tool number, your adjust register, cut com registers. You can specify all of these properties in here, and also your feeds and speeds, similar to how we established for the standard tool types, and save this as a new tool.
Uday, I just wanted to interject here. Can you bring up the dialog again, the user-defined tool dialog? One thing I wanted to note is you might wonder, why do we have the holder diameter here if you've already got the curve profile or the tool profile? What that allows you to do is actually use one profile and scale the tool for different sizes. So it's not just using the form of the particular profile, but we also have the ability to actually scale that profile. Thanks, Uday.
Thank you, Joe. So once we have this tool defined, you could save the tool to your library. So you don't have to go back and reselect the profile for each and every project that you're working on that requires the same tool. Or you could have, several different profiles, and you can have a library of user-defined tools defined, or they could be part of your same tool library which has your standard tools as well. Now once you have all of these defined in here, you could use the user-defined tool to program your toolpath. So in this particular case, I would like to program this profile in here. So the workflow would be very similar. So you go into your machining operations, and in this particular step I'm going to go to 2-axis and select profiling. And then I could use select curve edge regions, specify the part region, and then for the tool, you'll notice that now your user-defined tool is now available in here under the Tools tab. You set your feeds and speeds and clearance, exactly the same way how you would program with a standard tool. Specify your cutting direction. You could specify your cut start side. You could choose your cut levels in here. Since I just want to run one profile and the part region is at the bottom edge of the profile, I would just set it at bottom, and I can set the entry and exit parameters and then pick generate. So this basically computes and generates a toolpath, and it automatically figures out the compensation for the tool based on the tool profile geometry that you defined in here. And we now have the profile toolpath. As we go to the Simulate tab, when you run a verification, cut material verification, you will notice that it actually creates the form based off the tool that we defined in here. So user-defined tool and form tools are available starting right from our standard configuration. Standard through premium, user-defined tools are available. So now the next thing we're going to talk about is address some of the tools related questions in here. And for this I'm going to go over and cover these topics in here. So these are the different topics that we're going to cover. These are the commonly asked questions like where can I find the tool related preferences. So we briefly touched upon this topic in here. So if you go back into your CAM application and right on the machining browser, you will notice that there is preferences, and right under preferences you'll find cutting tool preferences. So right in the cutting tool preferences, the tool related preferences is it's automatically set by default to load the last loaded tool library on startup. Now since I have not chosen a tool library to load, as you can see here, the default tool library field is empty in here, so which means I have not specified a library to be loaded at startup, so it's not going to load any library. So the next time you load a library, it'll automatically map that folder path where the tool library and the file name it's set to, and it's automatically going to load that. Now there's one for English tools and one for metric tools, so you can have a tool library for English and metric tools, and you can have them loaded automatically. So if your workspace is set to inches, it'll load the inch tool library that you've chosen, and if your workspace is set to millimeters, it'll load the millimeter or the metric tool library that you've chosen. So this is where you'll be able to locate the tool related preferences. A lot of times I get questions asked, how can I print the list of my tools that are being used? So if you have a library of tools loaded in here, I'm going to grab another tool library, and you'll notice that I have a total of about 14 tools, and I could click on list tools, and this is going to list all the tools that are loaded from the library, so which means all the tools that are in your tools tab. Now selecting print will allow you to print this. You can print it, send it to your printer, or if you have a PDF converter, you can save a print and then you can choose a PDF converter as your program, so you can print it out as a PDF and have that information handy. Now I also have been asked several times questions like how can we output the list of tools in our posted output file in the posted G code. So you might be wondering, is there a way to print or list all the tools in the posted output file? Yes, there is an easy way to do that. In order to do that, you would have to set up a environment variable on your in your system environment variable preferences. I'm going to go over that. Now before I do that, I want to just add a couple of machining operations in here, and we'll show you how that information can be output. So I'm going to go ahead and quickly identify some features and program a couple of machining operations in here. So first thing I'm going to do is a facing operation. I'll pick a tool for that. I'll pick the face mill, generate the tool path, and then I'm going to pick the pockets in here, program a pocketing operation with a 1/2 inch end mill. So I have two operations created in here. Now as I go ahead and post-process these operations, I'll choose one of the post-processors in here from the list, and I pick post. You'll now notice that the tool information, the tool numbers are being output, but if you'd like to output the tool list in here, you would need to actually set up an environment variable, and I'm going to show you how to do that so the tool list can be output right at the start of your posted code. So you would want to go into your control panel, and you can go in there, edit environment variables or edit system environment variables. And as you go into your control panel and the environment variables under system properties tab, under the tab called advanced, you're going to find environment variables. And under system variables, you would want to add a new variable in here, and the variable name is going to be vcam underscore write tool list, all in uppercase, and then you can just set the variable value to be as 1. So I'm going to set that, and you'll now notice that the variable that you created is defined under system variables. So again, the variable name is vcam underscore write tool list, and you want to add this new variable in here. And I'm going to go ahead and minimize this posted output file, save this file. I'm going to close out of the application and go back and reopen it. And let me go back and load the part back. So we still have the same two operations in here. I'm going to right click and post process the setup. And I'm going to go back and repost it. And the posted code should output the tool name here. So let me take a quick look here. I may have had a typo in here. So as you specify the environment variable and specify a value for it, this would be outputting the tool list in the posted output file. So you need to specify the environment variable, and you would need to specify a variable value for it. And then once you post it, the tool list will get output in here. So I'll look into it to check why I was missing the tool list from being output, but I can verify that and get back to you on it. Now, if you also want to output this, this is one of the ways to do it. Now, sometimes we get questions asked, why are the feed rates in the posted code too high or too low? So one of the things you would want to check is in your post processor. So if the program feed rate is not what you're seeing in the posted code, you'd want to go into your feed rate tab or feed rate section in the post processor and make sure your high and the low values are defined correctly in the post processor. So if these values that you're seeing here for the high value, or if the values that you're seeing for the low value needs to be adjusted, you would need to want to make sure that you want to go back and update this in here. So for example, if the program feed rate in your machining operation is set to 350, but the high value in the post is set to 300, the posted output would cap it to the high value that you define in the post processor. The same thing works for low value. If you had a low value set to 5, but your program feed rate was 2 inches per minute, then the posted output file will set it to the low value that's defined in your post processor, which would be the value of 5 inches per minute or whatever value that you put in here. So you would want to make sure that these values are being set in the post processor, the high and the low values, depending on what it is, what your machine tool is capable of handling.
Uday, I just want to interject here a little bit about this environment variable that you set for listing the tools. I believe we'll have to regenerate the toolpath again to list it. And then the other, number 2, the note I would like to make to our users is, why do we have a complicated scheme of having an environment variable? Actually, in our 2018 release, this environment variable will be moved into a UI setting in a preferences is being done. And so the reason behind us using environment variables is sometimes when we get user requests and we don't want to make it available to all users, we use this sort of scheme. And once it's tested and proven useful, then we actually move it to the mainstream product. So that is why we have this environment variable set for now in the 2017 release. In the 2018 release, we will actually be moving it to a user interface. Thanks, Uday.
Thank you, Joe. So I'm just trying to go back in here and make sure I get the toolpath regenerated so we can go back and output the tool list in here. So I'm just going to make sure that I have the, if there was any typo in the, yeah, I did have a typo in the environment variable name. I apologize for that. So I should have mentioned that I should have the variable name had a error on it. So I'm going to go back and fix that in here and show you how we can output the tool list. So I'm going to go back and close the application in here, and I'll go back into the environment variable, and in the environment variable settings, the variable name should be vcam post. I missed out the word post as part of the first set of characters in here, so it should be vcam post underscore write tool list. I apologize, instead of vcam underscore write tool list, so I'm making a correction in here. So once I have made those, once I've added them into the environment variable in here, if I go back into the application and post-process the toolpath, right-click and post, I'm going to output it in here. You will now notice that the tool list is being output at the start of your output file. So the variable name is vcam post underscore write tool list. I had it initially set incorrectly, so that's the reason why you weren't seeing in the posted output file. Now you can see that all the tools that are used in your operation are now being output in here. Okay, so we'll move on to the next frequently asked question topic is, what about feed rates for tapping operations? Now for tapping operations, the feed rates can be output in different formats. So typically for a tapping tool, you would have your feed rate is computed as pitch times RPM for most controllers. So you would enter the thread pitch as part of your tool definition, and your RPM is set in the feeds and speeds dialog in here. So I'm going to use an RPM of 500 and save this as a new tool. Now, as you program a tapping operation, whole machining and tapping, and if you pick a feature and generate a tapping operation in here, depending on the post processor that you select in here. So for example, if I pick a different post processor from the list and I post process the machining operation, you will notice that the feed rate for tapping is computed based on pitch times RPM. So the macro in the post processor is set to a macro called cycle underscore IPR. If you notice the feed rate macro here in the post, it's using cycle IPR. This uses pitch times RPM for the tapping operation. Now certain controllers expect 1 threads per inch to be output as the feed rate for tapping. So you can replace this cycle IPR with a macro called cycle underscore TPI or cycle underscore 1 hour TPI. So all of these macros can be found right in your variable list in here. As you right click on the in the post generator where you can enter in your variables, if you right click, you'll see that there's a variable for cycle underscore 1 hour TPI. So when I insert this macro in here, cycle underscore 1 hour TPI, as opposed to using cycle IPR, if I save the post and I go back and repost it, in this particular step, the feed rate is going to be 1 hour 50 thousandths, which will end up being feed rate of 20, which is basically what the variable is going to compute and output the value. So you can output the tapping feed rates could be cycle underscore TPI or cycle underscore 1 hour TPI, or you could even output, it can compute the pitch times RPM to establish that. Now if you go into the help section, the online help section in here for tapping, you will notice that if you go to tapping feed rates, all of this information is explained right in here. So that's about tapping feed rates. Now, how could you optimize your machining time estimate? So as you take a look at the machining operations that you programmed in here, if you go to right click and choose information, it gives you an estimated time based on the parameters that you put in, like your cut feed rate, your spindle RPM, your step overs, your depth per cut. All of these parameters are used to establishing your machining operations info. It also takes into account your plunge, approach, engage, cut, retract, and departure feed rates. So you could go back and edit these parameters to optimize your machining feed rates based on your depth per cut, your step overs. All of these parameters are factored in when the machining time estimates are computed. So you can go back and optimize those, and then it'll establish the machining time estimates based on the parameters that you put in here. So for example, if I change the step over on the facing operation in here, if I change it from 25 to 40%, you will now notice that this affects your machining time estimate. So if I go back into information, you'll see that the facing operation now is little over 2 minutes or under 2.5 minutes. So you can optimize these by entering in the appropriate parameters for your step overs, your depth per cut, and also your feeds and speeds.
Uday, I want to jump in here. One of the things about the machining time computation is actually pretty simple. All we do internally is take the length of your tool path, take the entire length of your tool motions, and multiply it by the velocity of the tool, which in this case is the feed rate of the tool. So there's only two things that affect the machining time. One is the length of your tool path motions, and then number two, the feed rates you've assigned. So in order for you to optimize your feed rates for the machining time, these are the only two variables you're playing with. In order to reduce, if you want to speed up your machining time, you have to reduce the number of motions and or increase the feed rate. So that's as simple as that. So you got to keep an eye on your non-cutting feed rates. Those are the areas where you can optimize it most, because most of the time the cutting feed rates you're pretty much based on the material and the tool. And then of course, as Uday pointed out, step overs and cut depths will affect the length of the overall motions. So these are the only two ways you can do it. So hope that makes sense.
Thank you, Joe. So we have a few more FAQs in here, and I'll try to go over them. We may be running a little bit over time, but I hope all of our attendees are okay with it. So, so how can I add comments in the tool? So we did talk about briefly here, in the early part of the webinar. So you can specify comments to be output in here. So for example, I can, if I want to output the tool name as a comment, I can enter it right in here. If I want to output like an optional M code or a G code, I can add a prefix like $, as a prefix sign, and then specify the code that needs to be inserted. So when I make those changes and save those comments by saving edits to tool, and I'm going to go back and repost this out in here. So if I go back and post the entire setup, and you will notice that as we go from the first tool to the next tool in here, those comments are being output. As you can tell, the first one was just a comment. We just entered in the tool name. For the second line of the comment, I inserted a $, and I put in M00. So you can see that this is actually output as a it's a non-comment, which is basically a code, an M code that can be interpreted by the controller and not just as ignored as a comment. Now, if you'd also like to have the line numbers to be output with the comment, you can go into your post processor in here, and you have the option to output the sequence numbers for comments as well. So now when you go back and repost this code, you will see that the comments also will have a line number to it. So there is the comment and the next line, which is basically the comment we added to be as part of an M code and with a line number to it. So that's how you can insert comments. Now the comments can be inserted into the tool properties, or you can also insert comments under each machining operation. You can right click and go to properties. You can also specify comments. It can be a comment, could be a single line or a multi-line comment, and you can specify it here. And as you can see, the tool tips that pops up, or when you hover the cursor on each of these boxes, it says if you add a $, as a prefix, this would skip the comment start and end character. So there's a lot of help built into the product here, as you can tell. So this will help you in adding comments to each operation, or you can have the comments set for each tool in the program. Now the next thing we would want to cover is how can we add a tool change point that can be output in the posted code. So if you have a manual tool change that is involved, or if you want to move the tool to a specific tool change point so that it makes it easier for the operator to swap off the tools, you could go into your machine setup dialog in here, and you can specify a tool change point right under the general parameters. You can specify an XYZ value in here. So in this particular example, I'm going to put in a Z value of 3 inches. I'll leave the X and Y as 0. So once this parameter is specified in here, you would want to go into your post processor and you would need to insert those variables for a tool change. So before a tool change is performed, I could insert the variable for the tool change. I could say I want to move the tool change to an X value, Y value, and a Z value. So as you right click, you have all of these variables in the post processor, and we have a variable for tool change point X, Y, and the Z, and you can select the variable and insert it right in here. So you have the tool change point X. I'm just going to make a copy of this and specify one for Y coordinates and one for Z coordinate. If you want to do the Z first and X and Y, so you just basically split that up into 2 lines. You can basically have this in 2 separate lines in here. The first line you could do a tool change point Z, so you want to retract the tool up into Z first, and then the next line you could do a tool change point X and tool change point Y. So that's how simple it is to insert the tool change point macros into your post, and the values are specified under the machine setup dialog in here. So if you put in a value for X, Y, and Z, those values will get output. If you leave them at 0, it's going to output 0 for tool change point. So now I'm going to go back and post it again, and you'll now notice that in the posted code, it outputs a G0, Z3, which is the Z of 3 inches I put in, and then the X and Y is 0. So that's how easily you can insert a tool change point into your program. The next thing I'm going to cover is how I could enable cutter compensation in the program. So cutter compensation makes sense in 2-axis or 2.5-axis operations like facing, pocketing, profiling, chamfer, and this can be set in the operation. So you want to first go into your machining operations. In this particular case, I'm going to give you an example of a profile operation. I'll select the face edge on this model for a profile, specify a tool for it, and in the cutting parameters, you have the option to specify your compensation. So we're going to set the compensation to auto on, or you could pick control on, where the tool paths are still automatically compensated by the tool geometry that you specify. However, the compensation is what you're compensating is more like for a tool wear at the machine or the controller. So you would want to also make sure that the cut direction is always set to climb or conventional in order to output a cutter compensation. Selecting mixed will not output the cutter compensation. You would then want to make sure that you specify your cut start side, which side you want to cut. In the cut levels, you can specify the depth in here. You can make sure you specify an entry and exit. So you want to make sure in order to output a cutter compensation, you either use a linear or you could use a radial. Certain machines prefer linear over radial. You can specify these parameters in your entry and exit tab for cutter compensation.
Uday, I just wanted to mention that the first motion always has to be a linear motion for the cutter compensation to be turned on. That's why we have the approach motion there that's got a length, a tangent approach motion, which will always be a linear motion. So yeah, controllers cannot apply cutter compensation on an arc, so we have to have a linear motion.
Thank you, Joe. So once we have this specified, you'd want to pick generate. So the toolpath is generated, and you also want to make sure that your entry and exit is being applied in here. So if you're profiling on an inside corner and you're not seeing the entry and exit, even though you specified an entry and exit, and you're not seeing the entry and exit being applied in the toolpath, then you wouldn't be seeing the cutter compensation being applied. So make sure that your toolpath preview also shows the entry and exit. So once you have this specified, the key things here is to make sure your cut direction is set to climb or conventional. You have your cutter compensation set to either auto on or control on. You have an entry and exit specified. And when you generate the toolpath, make sure the entry and exit are appearing on the toolpath preview. And also you got to make sure that the post is set up to output the cutter compensation. So if you go into your post processor, you have a section for cutter compensation, and this is where you can define your macros for cutter compensation. Typically, when you turn on a compensation, For compensation left, you would use a G41, and then you need to have an XY motion. The same thing applies for compensation right, G42 with an XY motion. And for compensation off, you could just output a G40, or some controllers may expect an XY motion for that as well. You can put that in the post processor. And on some controllers, you also need to output a D value, which could be your Cutacom register value or your tool number. You can specify those in the post. And once you have those set, when you post process your machining operation in here, you will notice that it turns on the cutter compensation on the first linear move, and it turns it off at the exit motion. So that this is how we can apply and cut a compensation. And the compensation, the value that you're trying to compensate for tool wear is entered in your controller's tool table. The tool paths, however, are still automatically compensated by the tool geometry that you define for programming the tool path. So what you're compensating here is for a tool wear at the controller. Now this can be done in two axes, facing, pocketing, profiling, chamfer. The operations that allow cutter compensations, you'll see the compensation option under the global parameters in the cut parameters tab. So with this, I've covered most of the FAQ topics that we had for today for our webinar. I would like to go ahead and hand this back to my colleague Krish.
Unmuted.
Thank you, Uday. I know that we are running a little over, but I wanted to make sure that we also mention that a lot of this information is available to you in addition to the webinars that we do. We also have information available to you specifically on this topic in your Visual Serve login. And this is for the AMS customers, where you can log into Visual Serve and you have all of these resources available. And then we also have a blog article that was published. While Uday is navigating to just show you where you can find this information, I just wanted to make sure that we mentioned it. So you have access to this specific topic both through this blog that Uday is showing right now and through your Visual Serve login for the AMS customers. And our goal with these seminars is to provide you with as much information as possible so that you can be independent, you can be efficient in what you're doing, and these are all of the resources that are available. And as you may recall, this is our second seminar on the topic of tools and feeds and speeds and basically this area. So I just wanted to quickly point that out. I realize we're running a little bit late. With that, if there's any questions, please go ahead and we'll be happy to answer.